Take a deep breath. There are headlines screaming panic, but the first thing is to separate noise from data. Today I'm going to tell you what's happening with 3I/Atlas, why people are talking about anomalies, and what that really means for us. 3I/Atlas. Balas is a visitor that wasn't born here. Its orbit isn't a circle or a closed ellipse. It's a hyperbola. That, in simple terms, means it comes from beyond our solar neighborhood, passes through just once, and leaves forever. It's not a secret satellite, not a giant station, not a ship with windows. It's a natural object behaving as such, even if it has features that catch our attention. So why are some people talking about anomalies? Because compared to what we're used to seeing, it brings interesting oddities. Its brightness rises and falls irregularly. Sometimes we see a jet that seems to point in a specific direction. Other times the coma looks asymmetric, as if it's being blown to one side, and its movement doesn't fit a simple stationary point. It spins, wobbles, responds to the sun's light and heat. None of that, by itself, is proof of technology. It's rather the portrait of an icy body that's heating up and waking up as it approaches our star. Imagine a fragment of dark ice traveling through deep space for millions of years. When it starts receiving solar radiation, the most volatile layers sublimate. They go from ice to gas. That gas escapes through cracks and vents, forming jets that push dust and tiny grains. If the nucleus is irregular, if it's not a perfect sphere, those jets function like small natural thrusters that change the object's orientation. The visual result is striking: twisting tails, dust fans, flashes, spins, shadows. We see it as weird because honestly we don't usually have interstellar comets on hand for comparison. Can a jet align with the sun and look like a direct beam? Yes. Can rotation make the brightness rise and fall as if pulsating? Absolutely. Can the solar wind reshape the tail and generate structures that look geometric for a moment? Of course. Nature at cosmic scale is incredibly good at imitating designs that seem artificial to us. Meanwhile, observatories do their work. Telescopes on the ground and in space measure what the released material is made of, how much dust it liberates, how its temperature changes, and how fast it spins. They search for the signature of common comet molecules: carbon dioxide, carbon monoxide, water, cyanogen, metallic traces. Each detection adds a piece to a larger puzzle. What kind of world factory this visitor came from, and how similar, or different, the building blocks of other stellar systems are compared to ours. And now the question everyone asks: is there reason to panic? No. The orbital calculations are clear. Its trajectory isn't on an impact course. It will pass, approach the sun, shine brighter, then fade as it moves away and continues its interstellar journey. Panic sells clicks, science sells answers, and the answer here is that we're witnessing a unique opportunity to observe raw material from another cosmic neighborhood. Still, the anomalies have value. Something being atypical doesn't mean it's impossible. It means it forces us to think better. If the relationship between certain elements is strange, we'll need to explain why. If activity starts earlier or later than expected, we'll need to revise sublimation and porosity models. If the spin changes abruptly, perhaps the nucleus is lighter than thought, or it's losing mass from one hemisphere more than the other. This is how science advances, with hypotheses that are tested, corrected, and when necessary, discarded. It's also worth stating what isn't seen. No controlled maneuvers are seen. No pattern of lights consistent with an artificial structure. No braking, no zigzagging, no directed course changes. What we see is a natural body responding to radiation and solar wind. Any video mixing the sun on one side and on the other, a space city with little orange windows, is a creative illustration, not evidence. Does this mean there's no mystery? On the contrary, there's an excellent mystery. We're spying for a while on material that was born around another star. It's like someone brought you a rock from an unknown continent, and you could analyze its minerals, its fractures, its trapped bubbles. Each measurement tells us something about volcanoes, ice, atmospheres, and collisions that didn't happen here but out there in a system we'll never visit. With that context, let's put things in perspective. There's no imminent threat. There's no signal of we're being watched. What there is is a natural laboratory coming toward us, peeking in and leaving, and in that brief moment we can point our instruments, take spectra, measure brightness, track its rotation, calculate its approximate mass, and compare its anomalies with what we already know about local comets. If something doesn't add up, we adjust the model. If something surprises us, we publish, debate, and observe again. You might wonder if you'll be able to see it. It will depend on where you are, light pollution, whether you use binoculars or a telescope, and how much activity it unleashes as it heats up. Sometimes these objects gift us an unexpected peak and become visible to amateurs with modest equipment. Other times they remain shy and only large observatories can extract details. Either way, the best images and measurements will start circulating as it approaches, and believe me, they'll be fascinating. Keep this idea. Anomalous isn't synonymous with artificial. Anomalous means we need to understand it better. And that's the exciting part, because every time something doesn't fit, the door opens to learning. Sometimes the learning confirms what we intuited. Sometimes it forces us to change our minds. In both cases, we gain knowledge. So there's no need for panic. What's needed is curiosity, patience, and data. While the interstellar visitor crosses our sky, instruments will keep pointing, light curves will keep growing, and questions will become answers.